Welcome. We'll be proving parallelograms are, or I should say quadrilaterals are or are not parallelograms. These two are not in your notes. Actually, that first one would have been a good one to have in your notes. I would like you to write what is, got a little star there. If you don't have what you need, can you get two triangles congruent? That is a good helpful hint to follow. If you look and you go, well, there's not a lot there. Right? Can you get two triangles congruent? Because if you can get two triangles congruent, you have all the corresponding parts, which gives you a lot more information. And then it only works with triangles. That's why we try to get triangles congruent. There's no corresponding parts of rectangles or parallelograms, right? Because just because there's no shortcuts there. You need everything. But triangles, they have shortcuts. All right, so let's see what we got here. We are given some information. Let's start with that. Let's see if my pen will write. There we go. So I can see that I've got angle ACD. Right, so it starts at A, goes to C, and goes to D. That angle is congruent to DBA. There might be a problem like this in the practice. And that is a given. Let's continue with all the givens here. We also are told that angle CAD is congruent to angle CAD, I'm looking at CAD, and that would be BDA. Got to go in the right order. Right, that was given to us, and I can get a pair of sides parallel from that. We do have one set of alternate interior angles. The one with the two arcs, those are alternate interior angles, but that's only one set. The other two angles being congruent doesn't prove any sides are parallel because they're not alternate interior. But I got two sets of angles in a triangle congruent. If I can just get one pair of sides, one pair of corresponding sides congruent, I can prove the triangle's congruent, and then I can get anything I want congruent. And I think I can. I think I know that side AD is congruent to side DA. It does flip. Right? A goes with D, so if one is AD, the other is DA. Well, how do I know AD is congruent to DA? Well, that would be the reflexive property, because that is the exact same side. Doesn't matter that I can name it two ways. It is the exact same side. So now I can prove the triangle's congruent, because I've got two angles and one side in one triangle congruent to two angles and a side in the other triangle. So we now know that triangle ACD is congruent to triangle DBA. And the easiest thing for me to do is just use the angle, because the angle has it in the points in the right order. So I'll just use that order to name the triangles. And those triangles are congruent using angle, angle, side, triangle congruence postulate. Actually, I think that one is a theorem. Sorry. Not that it really makes that much a difference if you called it a theorem postulate instead of a theorem. Theorem just means it was proved off of something else, and it was proved off of angle, side, angle. Now that's angle, angle, side, because the side is not the included side. It's not between the angles. But now that the triangle is congruent, all the corresponding parts are congruent. We already have, I can already show that a pair of sides is parallel. Why don't we go with that, and then we can use the fact that these triangles are congruent to get a pair of sides congruent. Right? So I can surely say that AC is congruent to DB, and those are corresponding parts of congruent triangles are congruent. It's fine to write the abbreviation, just as long as you know what it means. All right, so that means this side is congruent to this side. And I have one of two choices here. Actually, why don't we just continue with that? I can prove the sides are, those same sides are parallel, or we can get the other pair of sides congruent. It doesn't make much of a difference, since it'll take me 2 steps to show the sides are parallel and only one step to show the sides are congruent. Let's go with sides congruent. All right, so AB is congruent to DC for the exact same reason. They are corresponding parts in congruent triangles. Right? So if the triangles are congruent, so are all the corresponding parts. That is enough to prove the triangle's congruent. So not triangle's congruent, excuse me. That is enough to prove that this is a parallelogram. We proved the triangle is congruent in step 3. So ABCD is a parallelogram. And I'm going to abbreviate that and put P-gram. That is an acceptable abbreviation. And the reason we know it's a parallelogram, it is a quadrilateral, and I can abbreviate that as quad, with 2 pairs of opposite sides congruent. I could have also proved that it has, actually could have proved any of them that you wanted, really, but that was the shortest one. The next shortest one is to say that AC is parallel to BD because they converse of alternate interior angles, and then you'd have 1 pair of opposite sides, both parallel and congruent. But that was one extra step. Now, I used up a lot of space here for that first problem, but the second problem isn't going to need much. And we're not going to do a proof here because it is quite apparent that this is not a parallelogram. All right, so quadrilateral is not a parallelogram. And that's because it is clear that the opposite sides are not congruent. Right? What we have instead, we have consecutive sides congruent. This is a kite. This is just a kite. All right, so now we're done with these two. All right, and these ones weren't in your notes. Not a bad idea if you want to add that first one to your notes. You would have space on the back of the cover. By the way, I have to say, that is a great cover. It has got a lot of information there for you. Right? And I think I got maybe 2 more proofs. Let's see. And actually, I know I have a note to myself to put one of the upcoming ones in your notes. I don't know. I almost think that one was already in your notes. Let's see. As soon as the page decides to turn. Any day now, Paige. We are just waiting for you. All right. Oh, and I wanted to put I forgot to move it back. Well, pretend you don't see that. I was going to erase the whole thing, but then I thought I would, would just put the screen up and move the screen, and then I forgot to put it back. I was just making the handwriting a little nicer. All right, especially in the middle. Hey, I didn't want it to go that far. Come back here. Come on. Good people are waiting for you, screen. Okay, perfect. All right, so here we have an example of for your notes of a proof. And I know I put this one in your notes because this is really very similar to the last few problems of the homework. All right, so put this little proof in your notes. The back of the front cover would be a great spot. And so it's an example, a sample proof. All right, and I already put the steps up there. Actually, I have everything up there, but we'll go over piece by piece. We'll explain all the steps, and we'll go over the reasons. So we are given that, as you want to draw the diagram, the beautiful diagram that I'm pointing to, that you can't see me pointing to, but I am pointing to it. And I'm going to mark what we're given. Always mark what you're given on the diagram. And if you're not given a diagram, draw one. AB is congruent to DC. So let's mark that. Angle A plus angle D equals 180. Now I will tell you this is very similar to a homework problem. All right, so it is similar to homework problem on the last page. So now if you take notes on this, you can use this to help you with yours. All right. So we have AB is congruent to DC, angle A plus angle D is 180. It's kind of hard to write that, the second one, mark that on the diagram, but we marked the first one. We want to prove that ABCD is a parallelogram. All right, so I hope that you already know the reason that AB is congruent to DC without me having to scroll this down. All right, that, oops, is the easiest one. Whoops, I'm looking for the cursor. I went to move it. Sometimes we have these little glitches when we're taping. The cursor likes to go hiding, and then I click on it, and then I open up Schoology instead. And here we go. It's very slowly moving. Very slowly moving. And I think I'm moving the word. Oh, I guess it got erased. That's okay. We'll add that in. And it's also for 1 and 2. Ah, man. Well, you just can't trust this thing screen at all. 1 was missing, but we'll add it. And it wants to keep moving anyway, even though. Fun with screens, although I'm not having fun doing this, moving the screen back and forth. All right, so number 1 was given. Angle A plus angle D equals 180 is also a given. All right, so we started off with our givens because there's not much else we can say until we say the givens. Angle A and angle D are supplementary. Well, how do I know they're supplementary? Well, supplementary angles add to 180, and you better behave, Mr. Screen. There we go. We're just going to let it keep on going. Angle A and angle D are consecutive angles. Well, consecutive just means they're next to one another. All right, so I only have one pair of consecutive angles that are supplementary. So I can't use that reason. One angle is supplementary to both its consecutive angles. I only got one pair consecutive. So that is not the way I'm going. However, because the consecutive angles are supplementary, let's get rid of that screen. Because the consecutive angles are supplementary, the lines have to be parallel. So AB, now I can mark AB is parallel to CD, and the reason is consecutive interior angles are supplementary if and only if the lines are parallel. It's the converse of the consecutive interior angles postulate. Right? That means that the ABCD is a parallelogram because it's a quadrilateral with one pair of opposite sides, parallel and congruent. Oh, look what happened. There's the given. We'll get rid of them. All right, so this is very much like a problem on the homework. Hint, hint. It is one of the last 5 problems. I'll give you that hint. All right, so the homework, I think it's 2 pages. It's the second page, so it is somewhere between 21 and 25, right, is a problem just like this, right? Maybe 2. Maybe not exactly like, not both of them not exactly like this, but both of them might use this little piece right here. That if you have consecutive interior angles supplementary, the lines have to be parallel. All right? So if you need some time to put that in your notes, go ahead and pause it. If you ever have questions on anything that's in a Nearpod, just email me. I check that email often. Oh, and that means that it's time for me to stop my video because I wanted to separate the proofs from the solving, and I thought I had erased that page, but I didn't bother to, and I forgot that this was the last problem in this video. So this is a little bit of the short video, so this would be a good time to do some homework, and because it's only 14 minutes of video today. And I will put in on Schoology which problems you should do. Right? So we'll break this homework up over this week, over the week, and over the next week as well, because there's more videos to come for the rest of this homework. All right, well, thanks for watching, being able to prove that a figure is a parallelogram. In the next lesson, we're going to solve for missing measures in parallelogram. So we're going to use the fact that we know the opposite sides are congruent and the opposite sides are parallel and the opposite angles are congruent and the consecutive angles are supplementary to find missing measures. All right, so thanks a lot for watching. Bye for now.